So, we're going to take a look at hyperbolas. Now, hyperbolas, honestly, some people think of them as the inverse, as far as the graph goes, of an ellipse. Essentially, if you imagine an ellipse, cut it right down the middle, and then point it outwards, then you'd get essentially a hyperbola. There's some actual versions of geometry where hyperbolas and ellipses are the same thing, behavior-wise. They both have a foci. They both have vertices. But here, instead of the distance from a point to each focus always adding up to the same thing, when you subtract them, you're always going to get the same thing. The difference of those two will always be the same. Okay. Terminology-wise, you still have the A value and the C value. A is still center out to vertex. B is still center out to focus. But the difference is, instead of a major axis between the two vertices, you have what's called a transverse axis between the two vertices. The midpoint of that axis then is where your center is. So halfway between the foci, halfway between the vertices. That's the same thing as what it was for an ellipse. The difference is the B value, there's no minor axis to work off of. Okay, so what they do instead is you have asymptotes. Now, equation-wise, formula looks almost the same, except for because it's a minus sign, the order you write this in matters. The size of the denominator is actually irrelevant here. It's just whatever fraction is positive, that's going to determine horizontal versus vertical. So if you have the x first, that means your transverse axis, in other words, your entire shape, is going to be horizontal. If the y is first, your transverse is going to be vertical. Now notice, they always just put the A value there. Okay, so A doesn't automatically mean go the biggest value. It can change from going vertical to going horizontal based on what's first. Nice thing is, as far as finding the foci, that thing is just flat out the Pythagorean theorem. So if you have a minus in your equation because it's a hyperbola, that means you're going to have a plus for the c squared. If it's a plus and it's an ellipse, that means you're going to have a minus for a squared minus b squared. It's always paired opposite. Okay, so looking at one of these, somewhere, there we go. Find the standard form of the equation of the hyperbola with foci 0, 0, and 8, 0, vertices at 3, 0, and 5, 0. So where do I start? Draw it. Graph it. 0, 0. And I call that 10. 8, 0 would be there. 3, 0. And 5, 0. So what does that tell me? 4, 0. Halfway between each pair of those things is your center. You know what?
A and C.
What's A?
A is 1.
A is 1. That's the distance to there. And C? 4. So yeah, c squared is equal to a squared plus b squared. So you have 16 is equal to 1 plus b squared. So b squared is equal to 4 is from the center out to this point. So that's your C value. It's from center out to the focus, either focus. So for equation-wise, what's going to have to be first? Well, A is always first, but is the x first or the y first?
X is first.
Why?
Because it's horizontal.
Because it's horizontal. This transverse axis is horizontal. That means I'm going to have x first. It's always going to be minus for a hyperbola. And then plug in your values. So when I do this, the center, the 4 is 0, so what's that mean? plus nothing, so deal with that in a minute. What's underneath the x minus 4 squared? 1 for the a squared. And underneath y, the y squared? 15. So clean it up a bit. Your equation would look like that. Not bad? Okay. Now with these, if I want to draw them though, I need to take the asymptotes into account. Now, the asymptotes will always follow the format of going from the center. It's going to go either horizontally or vertically based on where the vertex is. And then that b value, that other value is how far you're either going to go up and down or left and right, depending. It's the other value. Once you have that, honestly, I just draw the box here and then draw the diagonal. Okay? So the idea, if you just make that rectangle, draw the diagonal through the center and through each corner of the rectangle, that gives you that value. Okay, so that will always yield your asymptotes. But the thing is, if they're opening up or down, remember that a value is going to switch from, or up or down or left or right, that a value is going to switch from vertical to horizontal. It's going to switch from rise to run. So you actually have two different versions of this equation for the asymptotes. If it's horizontal, well, that means your vertex is, a value is horizontal. So your a value is the run, your b value is the rise. If it's vertical, that means that a value goes up and down. So the a is the rise, and the b is the run. And honestly, usually I'll write it like this instead, just when I'm setting it up. Because then those values there, these two sides, they're literally just straight off the numerators. That's just what you're squaring. And then the fraction in front here is either going to be b over a or a over b based on vertical or horizontal. So let's bring that into play. If I want to sketch this hyperbola, what do I have to do first? Put it in standard form. How? Do what? Divide by 36. So if I divide everything here by 36, what am I going to get? Y squared over 9. Is equal to 1. So, where's the center of this at? 0, 0. So center at the origin. Where are my vertices at? Yeah, so you're going up 3, down 3, and that's where my vertices are. Then how far would I go left and right for that other reference points? 2. I'm not going to put a dot there because, well, it's not actually there. But I'm going to draw that rectangle through those. And since I'm just sketching it, then from there I'm just going to draw the diagonals. Now, which way is this thing going to open? Up and down, vertically. So it's going to skim along one asymptote, come in, hit that point, and make sure you hit the vertex, not the foci or the center. I have some people that will draw this all the way to the center and out. That's usually more in FS&T than in here, though. But there's your hyperbola. Questions so far? Okay. Let's kind of look at worst case scenario. It's asking you to do pretty much everything. Sketch the hyperbola given by that equation. Find the equation of the hyperbola, its asymptotes, and its foci. Say again? Complete the square. What do I need to do to complete the square with the x's?
Wait,
What?
you don't have.
You don't have to. There's only x squared. You just leave that alone. What am I going to have to do with the y's, though? So you got a -4. Leaving you with? Okay, then I'm going to add in the blank that I need to have, and I'm going to move the 40 to the other side. The nice thing is I only have one blank here, so I only have one blank here. Then what?
Take half and
Take half a -2. That's going to go down here. What's half a -2?
-1.
So then what goes in this blank?
1.
1. So then what goes over here?
Negative.
-4.
Tricky.
So it's going to be equal to 36. Then what? Divide by 36. So I end up with x squared over what? 4. And y minus 1 squared over 9. Okay, that's enough to get a start on the graph. Where's the center at? 0, 1. Horizontal or vertical? Horizontal. So I'm going to go just up 1. Where am I going to go from there? To the vertices, let's say. How far? 2. Left and right 2. From that center. How far up and down to get my reference points? 3. And then draw your rectangle. So, that's enough to actually generate the entire graph. What do I still need as far as the problem goes, though? Asymptotes and foci. Wow, that wasn't to scale at all. There. Pretend that's going through there. Anyway. Which way is this opening? Left and right. Okay. So from there, foci. Actually, before I do foci, easier than that. For the asymptotes, here's where I'm going to set up that equation. The y minus 1 on the left, the x minus nothing, so just x on the right. It'll always be plus or minus. Then the only trick is, what's your rise, what's your run? That's why I like graphing at first or doing a rough sketch, because it's blatant what your rise is. From center up, how far do you go? From center up, 3. Now, how far do you go for those reference points? And how far do you go left and right? 2. That's your rise over your run. So then just simplify the equation. You get plus or minus. If you can, simplify the fraction. Plus 1. There's your asymptotes. So I got my graph, my equations. What else do I need? Foci. How do I find the foci? A squared is what? B squared? And actually, since you're adding these, does it really matter which one's which? No. That's equal to c squared. So c is going to be equal to square root of 13. Now, foci are going to be coordinates. I need 2 of them. So where are those going to be at? You're going to start at the center and go where? Square root of 13, which way? Plus or minus, yeah, left and right. So I'm going to go up to this 0, 1. Then I'm going to go left and right. So that's going to change the x values to either square root of 13, 1 or negative square root of 13, 1. And that's the last part of my answer. Questions on that one? That's kind of the everything in the kitchen sink thrown at you problem, so. Okay. This is one that just looks weird. Problem. Find the standard form of this equation for the hyperbola that's vertices 3, 2, 9, 2, and asymptotes are those two that are given. Honestly, I don't usually bother with the asymptotes too much because the vertices tell me a lot about this graph. First thing, draw 'em. So 3, 2, 9, 2. That alone tells me what about this graph? Horizontal. So I'm going to have x squared first, then minus the y squared is equal to 1. What else does it tell me? Center's where?
6.
Yeah, halfway between 3 and 9 would be 6, 2. So there's your center. So here, minus 6, minus 2. What else does it tell me? Well, I'm not getting to this yet. I can still get one more piece of information out of these two vertices. A. What's A? 3. Because the idea from here to here is 2A, right? So then A would be equal to 3, which means what does that give me about the equation? 9 is where? Under the x. So if 9 is under the x, now I can work with my slope. The slope of these asymptotes is 2/3, right? Well, the idea is this will always be rise over run. Well, I know one of the numbers. A is 3 here, right? So is that the rise or the run? The run, because it's under the x. If it's under the x, it's affecting it horizontally. That means that's your run value. So if this is 3, then b is, and b squared is 4. So there's your equation. Now if this would have been, instead of 9, if this was 81, okay, then what number would be down here? 9, which what would b be in that case? 6. So you got to make sure you simplify the fractions, okay, or unsimplified if you want to think about it that way. Okay. Let's see. One thing application-wise, there's a couple different places this is used. Let me actually do this first. One is when you're doing kind of like essentially echolocation, sort of. If you're just actually trying to find something by a sound, okay? In other words, sonar. You ever see out at the airport, they have those giant radar dishes? Now, notice though, they're not a parabola pointing one direction, right? They literally have two sides. Well, that's a hyperbola. What that allows it to do is, as stuff comes into it, you get a little bit of different behavior. If you're looking at an ellipse from one focus, any energy generated will bounce around and go to the other focus, right? For hyperbola, what ends up happening is any spot on that surface will always be in a straight shot line from one focus and the other focus. Well, if you detect anything hitting some certain spot there, between that, they can figure out where along that hyperbola that thing exists. Okay? This does a slightly different version. This is actually putting things a mile apart and looking at sound. If you could hear an explosion, that the sound here and here is heard 2 seconds apart. Well, that means the difference of travel from here to here and here to here, well, would have to be that 2 seconds difference. So this is 1,100 feet per second. If sound's traveling that fast and it takes 2 more seconds to get here, that means this spot is 2,200 feet further away than what this is, because that distance will always be, or that difference will always be constant. So they don't know where along the hyperbola's explosion happened, but they can get it. They know it happened on that hyperbola somewhere. They can generate what that hyperbola looks like. 2 points isn't enough to get the exact location, though. What do you need for that? 3, and that's called when you use 3 points to figure out where something is happening away from you. What?
Triangulate.
Triangulation. That takes 3 points, though. Another place this comes back up is in elliptical, well, in orbits. There's actually, we really mainly talk about elliptical orbits, but there are parabolic and hyperbolic orbits as well. Usually these are things that are traveling extremely fast to the point where the sun's gravity is not enough to completely overcome them. It'll affect them. It'll bend their path and turn it into a parabola or a hyperbola. But the thing is, will we ever see that object again? No, if it's traveling along a parabola, it's going to go right back out of the solar system. Okay, and those are the ones that are usually traveling extremely fast. Now, the good thing is, at least luckily in our solar system, what do we have blocking for us? Now, an asteroid belt is actually, when you see that in like sci-fi movies and stuff, and it's about space, those asteroids are nowhere near each other. They're hundreds of miles between them. They make it look like they're all on top of each other. They're really far apart. Those aren't blocking anything. We have a much bigger thing blocking for us. Not counting the sun, what's the biggest thing in the solar system? Jupiter. Jupiter is so large that its gravity affects pretty much anything coming into the solar system. And is usually enough to bend it and break them up, to the point where we have comets that'll slam into Jupiter once in a while. Anybody know one of the most recent ones? Have you heard of Shoemaker-Levy? That thing hit with more energy than what, if we set off every nuke on the planet, it wouldn't equal anywhere near the amount of energy that thing expended. If that thing hit the planet, like ours, yeah, we're kind of over. Anyway, and the thing is about the ones coming into the orbit, the ones that we come across every so often, we can see those.
We're kind of done.
Okay? The ones that are coming in on the hyperbolic orbits are coming in so steep and so fast relative that we don't see them until they're pretty much here. And statistically, we're fairly overdue for one to hit.
Please don't say that.
Anyway, average is about every 200,000 years or so, which we're about 50, 60,000 over that.
God. No, we'll have some time to just use like the laser or something to just.
It's if you know it's coming, if it's moving slow enough. For this, last thing. If I want to classify a conic section from its standard, I don't actually need to manipulate. I don't need to complete the square. I can just look at the equation and figure out what's going on with it. Because the thing is, if you think about the structure of a circle, well, a circle is essentially an ellipse where the two denominators are what? Equal, the same thing. Well, if you're going from this structure, that means the coefficients would have to be the same value. So as long as you have the coefficients on your both squared terms equal, that's a circle. Parabola is the easiest one. Look at this equation. What are you not going to have if it's parabola? Or what are you specifically going to have? Right, you only have to have, if you have a single x squared or a single y squared without the other one, it's a parabola. Mathematically, that means one of them is 0. One of your coefficients is. Ellipse-wise, it just means your two signs are going to be the same on those squared terms. If you multiply them, it's going to be positive. And hyperbola, one's positive, one's negative. So looking at this, where's the circle at? B. These both have a coefficient of 1, so this is your circle. The other easy one, where's the parabola? C, because there's no y squared. What are the other two? D's what? D's the ellipse. Now it's only one left, it's hyperbola, because both of these are positive here. One positive, one negative. Questions on any of it? Okay. The rest of the time is yours.